If that service is unavailable for a period of time, basically your entire application that's behind it is going to be unavailable. So you could see how the $114,000 of revenue impact is not really, going to be made up for by the $1,000 of SLA credits.
Welcome to AI Cloud Horizons, the podcast where we have honest technical conversations with the people shaping the future of infrastructure powering the most demanding AI workloads. We're going to discuss everything from cutting-edge hardware to taking models from pre-training to production. We'll have insights on all of that. My name is Jacob Feldman. I'll be your host. And in this episode, we're going to discuss some of the unique challenges around AI cloud reliability, what to expect, and why standard service level agreements just don't cut it anymore. With me is someone who deeply understands these challenges, John Mancuso, the Vice President of Customer Experience at CoreWeave. He's spent years in the trenches working with AI labs and enterprises to keep their infrastructure stable. For the past 14 years, he's been at all three of the largest legacy cloud providers, leading teams that work with some of the biggest names in tech. John, welcome to the show.
Thanks, Jacob. It's great to be here. Looking forward to the conversation.
Me as well, absolutely. So, like I mentioned, a lot of our conversation today is going to revolve around reliability. Just to set the stage for folks and provide some context, what do you think about when you hear cloud reliability?
The first thing that comes to mind actually is a story about when I was interviewing at AWS. So before joining AWS, I was a customer from 2008 to 2011. In the interview in 2011, it was April of 2011. They were talking about reliability, actually. And one comment that the interviewer made to me was, if an entire region goes down for AWS, that would be end of life for AWS. And the reason why he said this is because the way that AWS designs things is there's supposed to be multiple availability zones in any given region, and the availability zone could go down, but never a region. That was one of the thinking of the time. I can't make it up, but literally that next day, there was something called the EBS storm, Elastic Block Store storm, and the entirety of Northern Virginia was, for all practical purposes, down. And so I said to myself, well, I guess that's that. I mean, I went on about trying to recover what I needed to recover for work. And then I said, well, I guess I'm not going to go work at Amazon. But it's not the way that it played out, as everybody knows. I went and talked to my management and said, I know that there was this big problem where they had this outage, but we were able to recover quickly. And I'm sure that's what most other people did as well. And, life went on. The big takeaway for me after that moment was basically everything fails all the time. And so you have to design for failure. That's the idea of resiliency, right? Like that's much more important than counting on, every component being healthy all the time. And SLAs really are not the most important thing in the world. What matters is making sure that you can get your system stable quickly after any kind of outage or incident.
I have to imagine, for you in that place as a customer, probably the way the provider responded to it, the support ended up mattering a lot more than, the specifics of the incident in the end, right?
Yeah, absolutely. At that moment, that was true. And today, especially at CoreWeave, even during an incident, we have our product engineers communicating directly with customers, explaining what's going on, making sure that they have an idea of what to expect when the service may be recovered and available for them to continue.
I have to imagine also it's such a huge resource to be able to get all the expertise that a cloud provider can give when there's a problem. Rather than if you were on your own and dealing with this, on-prem.
Absolutely. Again, I mean, I think whether it was, again, back in the old AWS days or today at CoreWeave specifically, we operate hundreds of thousands of GPUs. That allows us operational experience that would basically be impossible for any individual company to do on their own. And that operational experience is translated to every customer of ours.
So what does resiliency really mean in the AI world? Could you give me a kind of real world example of, let's say, a training job, a few hundred GPUs? What happens when you encounter failure?
Yeah, so maybe relating back to the app world again. In the web app world, typically what you try and do to design for failure is you scale out. Instead of having one big machine, you break that big machine down into a bunch of small machines. And so if any one component fails, you can have a load balancer and distribute your load across those machines, or even, again, multiple zones, multiple regions, that sort of thing. The AI world really is completely different, especially when it comes to training. What you need to do when it comes to training AI models is typically take a bunch of small machines, or they're still actually quite large, but take a bunch of machines and combine them into an AI supercomputer. Let's say if you say 256 GPUs, that's 32 nodes at eight GPUs per node. If any one of those nodes fails, the entire job that's running, the entire training job comes to a halt, because again, you're trying to make those 32 individual things look like one big supercomputer. So it's really a completely different paradigm than what we've had to do in the past. So what you try and do to recover from failure is assume, again, that maybe one of those nodes is going to fail, or one or more of those nodes is going to fail. And then you need to get a healthy node in place as quickly as possible.
And I'm assuming that's a pretty involved process, even though it sounds simple, right? I think we'll talk about it a little more later, but just even figuring out when something goes wrong, I'm sure is a huge challenge.
Yeah, absolutely. Absolutely. So, I mean, I think if you think about the different ways that you may be building a cluster, maybe you'll do this on premises yourself, where you buy 32 compute nodes, right? Like network them together and have them set up that way. If you bought 32 nodes and you need to put another one in because one failed, well, you're kind of out of luck, right? If you're in a cloud provider, a traditional cloud provider, when one has a problem, what you may end up having to do is call support and then prove to the support agent that there is a problem with one of your nodes. And eventually they'll get you a replacement one. That interruption can take days for you to get through.
Right. And what does that kind of time to recovery really mean for those folks? When there's interruption, what does that cost the customer?
It's significant, right? Like these, at market rates, 32 compute nodes. Again, this is just a relatively arbitrary number, but 32 compute nodes is about $1,500 an hour to run. So again, if you're having to wait days to recover, that's a significant amount of money that you're losing on the other 31 healthy nodes that are there. But probably more importantly for these businesses is now it's giving their competitors a chance to get ahead, like while they're waiting to get their environment recovered.
Right, and this is an intensely competitive industry. I think a lot of our viewers will know that, but certainly from our perspective, I'm sure you see how competitive this can be.
Absolutely, seconds matter is really what it comes down to here. And so, the CoreWeave approach is to have extra capacity available that we keep within what we call our fleet ops cluster. And so first step is detecting that a problem has occurred. And once we have identified that there is a problem, basically taking that unhealthy node out of your cluster and replacing it with a healthy one just as quickly as possible. And in many cases, that's less than half an hour for our customers.
So we already mentioned that, there's this great process for replacing nodes and how big an impact that can have. Just speaking more broadly, what do you think is different about the way CoreWeave approaches these sorts of challenges versus, other providers?
So it really starts at the very beginning for us. Before a node enters a customer's cluster, we go through a burn-in process, a very extensive burn-in process with very tight tolerances. What this process does is make sure that the node that you're going to get is performing, like I said, within a very narrow range of specification. So that's going to mean that you have the highest performing GPUs in your cluster, and also the most reliable, because again, we put them through an extensive set of burn-in testings. Then once the GPU is in your cluster, we don't stop, right? Like we continue to run what we call HPC verification to make sure that it's performing at the specifications that you would expect. This only happens when your jobs are not running. So maybe in between the stop of one job and the start of another, we'll start running this HPC verification process. And then whenever you start up a job, you don't have to think about this at all. We'll preempt that process so that you can run your job just as you would expect.
It's almost like, they're kind of always ready for action, right?
Yeah, exactly. Making sure that the cluster that you, again, paid a significant amount of money for is doing the work that you expect it to do. That's the goal here, is to make sure that you're getting the most amount of value out of the cluster you've purchased from us.
Obviously, you spoke just there about, a good amount of automation, but what do you think the overall role of automation is in this process versus, human intervention, and kind of where do you draw that line?
So I think the most important thing for human experts to do is design the automation, right? Like we talked about seconds mattering greatly here, right? So if humans are in the loop and in the recovery process, let's say, then it's going to take time. But what we can do, because CoreWeave operates, again, at scale, hundreds of thousands of GPUs, is observe where problems exist and then build that into the HPC verification processes that I spoke about, and lots of other automations that we have in the platform to make sure that we can recover extremely quickly on your behalf.
And would you say that this automation is pretty unique to CoreWeave?
Yeah, absolutely. In my experience, if you're in one of the other cloud providers, when there's a failure, like I talked about earlier, you would have to report that failure, that incident, through a support channel to the other cloud provider to be able to address it. But the automation that CoreWeave has developed makes sure that you're able to get a healthy node back extremely quickly.
I guess in some way we're kind of operating as part of the team, right? Including the
Absolutely.
automation.
Yes, 100%. I mean, my role at CoreWeave is the head of customer experience, and that's exactly what I like to talk to all of our customers about. That everybody that's on our solution architecture team and the support organization is really an extension of the teams of of our customers, making sure that their clusters are healthy, knowing as much as they possibly can about our customers' business and what they expect to get out of the cluster, so that they're able to get the uptime that they want out of their clusters.
Can you tell us a story, kind of applying what we're talking about, where the approach that CoreWeave takes turned a near miss into a win, or maybe prevented a disruption altogether?
Yeah, for sure. So first thing I have to say is that we do need to respect the privacy of all of our customers. So I won't mention any customer by name, of course, but we have one that comes to mind where this is a customer with a cluster of about 12,000 GPUs. And we recently did a readout to their executive team. And in that readout, what we saw was an average of 9 automated recoveries per day. Every single day that CoreWeave operates their cluster at that scale, there's 9 things that, maybe in another place, whether they were running it themselves or in another cloud, there may have needed to be some human intervention. Now, these are not all like major hardware issues. Some of them could just be something like an uncorrectable ECC error. This is relatively common, and that would require a reboot. Again, CoreWeave is able to detect those and mitigate them without any interruption, to any extended interruption to the customer's jobs. So basically, things that may have been a major issue in another provider is just a blip in CoreWeave.
Going back to kind of what we were talking about earlier, I'm sure that has a huge impact on the kind of total cost of operating that, or the time to market for this customer, right?
Yeah, remember we were talking about just a small number, 32 nodes or 256 GPUs is $1,500 an hour. You can imagine what those numbers start to look like at 12,000 GPUs or 32,000 GPUs or 100,000 GPUs, which is some of our customers are getting towards these days.
Yeah, wow, awesome. All right, so now we have the fun job of translating this into service level agreements, which I'm sure is everyone's favorite topic. So kind of starting from the beginning, can you describe for folks who are listening or watching the podcast, what is the service level agreement, and I guess why does it matter?
SLAs, like you said, a service level agreement, is basically a commitment to a certain amount of uptime for the service. And if that uptime ever drops below whatever that commitment is, then the provider will give some amount of credits to the purchaser, right? So a very typical kind of SLA that you'll see is 99.95%. In that case, that means that the service could be out unavailable for 0.05% of the month. Translates into about 23 minutes, I believe, a month. and then there would be some sort of credit associated with it if there's more than 23 minutes a month of outage, if that's your SLA. Now, I'm just going to again relate this back to the pre-AI world, and why that you really need to think about how important these kinds of SLAs may be for you as the consumer. A very typical example may be something like an API gateway. The way that other cloud providers work is they typically have like a number of services that get built into a product, right? And so an API gateway is just one kind of service. And again, every one of the cloud providers has these, so this is not specific to any one. If that service is unavailable for a period of time, basically your entire application that's behind it is going to be unavailable. But the thing about the API gateway is it's usually really inexpensive part of the overall picture for a customer. So just putting some specific numbers here, let's say a retailer that makes $1 billion a year, that's about $114,000 an hour of revenue that retailer would get. Now, if the API gateway is unavailable, again, for that period of time, for an hour, it's a little bit more than the 20 minutes. So there's definitely going to be some sort of credits that are associated with this. But the typical kind of charge for a gateway in this scenario might be $10,000 a month, something to that effect. So the credit, if you're talking about a 10% service credit on that, might be $1,000. So you could see how the $114,000 of revenue impact is not really, going to be made up for by the $1,000 of SLA credits.
So in that way, they're important to know about, but there's also a challenge when you're understanding the impact of this. It's just like you were saying with the cost of downtime on, AI training clusters, right?
Yes, exactly.
So what tends to break down with traditional SLAs? Let's, I guess, be a little more specific about that. What are the kind of failure modes you see most often at these, legacy cloud providers? And how do those traditional SLAs just break down in the world of AI?
If you look at the compute SLAs again, at the other providers, they're usually broken down into two pieces. The first one is something like a multi-zone SLA, or also called regional SLA. And this relates back to what I talked about at the very beginning, is their assumption is that you can spread your compute across multiple zones within a region. That's really how they've designed their entire kind of networks. And the second thing that they have is like single instance SLAs. So if you think about the multi-zone SLA, what it says is like if you have compute deployed across multiple zones, that's when the SLA applies. But if you deploy only within a single zone, that one simply does not apply. Why does that matter in the AI training world? Because we talked about having to glue a bunch of compute together to look like one really big one, right? And so that requires really fast networking. Typically, in our world at CoreWeave, what we use is InfiniBand to connect our GPU nodes together. You really want low latency, high throughput kind of network connectivity. And that's just not going to be possible if you're talking about across multiple zones that need to be geographically separated. So that entire SLA really just doesn't have a value to customers that are training AI models. And then if you think about the single instance SLA, what that basically says is when a node fails, the service credit will be for the amount of time that node is unavailable. But like we talked about also, when you think about a large job of being a collection of many nodes, one node is not necessarily the thing that you need the credit for. It's the entire cluster, basically, that you need.
One bad node and kind of the whole cluster is unusable if your training code is looking at to run at a specific scale or anything like that. Right?
Yes, that's right.
Yeah. And I have to kind of imagine as well that this relates back to some of the ideas behind traditional high availability. That's I guess a little bit of what you're talking about with multi-zone, and that just doesn't apply anymore.
Not in the AI training world. Where I will say that it definitely still has some relevance is for inference, where you can be running your model on individual nodes that can actually be spread across multiple zones, multiple regions. But in the training world, again, you need to have everything as close together as possible, so you can get efficient training runs.
So shifting away for a moment explicitly from SLAs, I want to talk more just kind of generally about GPU reliability. In your mind, what is one of the more misunderstood pieces of of the puzzle?
No, I have a friend who recently went out to build a startup that doing AI training, and I explained to him a lot of the things that we've talked about so far, and just wanting to do this at as low budget as possible instead of buying GPUs from us. He went and found hardware on a third-party marketplace, and decided I'm going to build my own rack. And so he did that. He got the GPUs he needed. He got the rack. Decided, or when he plugged it in, he blacked out his building. And then after he got it powered back on, then he had some trouble keeping the temperatures, the thermals right, and then some networking issues. So after that, he came and said, "Can we get a cluster from CoreWeave?" And we of course said yes. And he's like, "This is the most amazing thing ever. Like it just runs." And that's really the misunderstood part is just really how difficult it is to operate large GPU clusters at scale if what you're used to doing is running, a research lab. Like there's a big difference between running infrastructure and what AI researchers typically do.
And I imagine the way you think about the goals of CoreWeave is to kind of abstract a lot of that away, right?
Exactly. That it just works. When you get a cluster from us, that from day one, you can start running your training jobs. And that goes to all the reasons that we talked about between the automation and our support teams being able to get you going quickly. That's our goal.
Awesome. So, in addition to this, we've talked a lot about day one. You just, have mentioned it. For day two and as, these kind of interruptions arise, what kind of role does observability play in all of this?
To be able to fix a problem, you need to know there's a problem in the first place, right? And so observability is key. It's key to us as the operator of the cluster to be able to, put the automation into place that we've been discussing, but it's also key to you as somebody who's running your, training your models on CoreWeave. Some of the things that we do that's different is all of our compute nodes are bare metal. And so that allows us to give our customers access to all metric data from the thermals that we've been talking about, the power, all sorts of like network bandwidth, whether you're talking about InfiniBand or Ethernet, statistics on everything that they could possibly be doing with the clusters. And then for certain levels of scale, we have customers that have their entire, basically have an entire InfiniBand fabric or entire data centers. We're able to give them, just every bit of metric data that we produce, which is incredibly valuable to them.
So tell me more about that. What is most valuable about giving customers all that transparency?
Well, it'll help them determine if there's a problem with their training code, first off, or with the infrastructure that's running their jobs. This actually comes into something more recently for CoreWeave, where we just made an acquisition of weights and biases, and announced at the Fully Connected conference that the observability data from CoreWeave can flow into weights and biases model
Oh, wow.
application. And so now researchers will be able to tie infrastructure errors into what they're looking at when they're training their models.
So that's really a full stack level observability, right? So
Yes.
so we're talking from temperatures all the way to how your training code is running.
Yeah.
I'm sure that's a huge benefit for customers who are working on these large kind of crucial operations.
Yeah, absolutely. In addition to the weights and biases thing, we also have other software layers. One of them is called Slurm on Kubernetes. And with the observability data that flows into Sunk, we're able to automate job recoveries. So basically, when there's a known hardware interruption and a job stops running, we're able to allow the customer to automatically requeue the job. And again, your goal is to get to the end state of a trained model as quickly as possible. So having that kind of automation through different layers of software is going to be a big advantage for customers of CoreWeave.
Right. I guess in a way, we've talked a lot about automation and how important it is every second. In a way, the observability, by the time you see there's an issue, that problem is probably already solved, right?
That's the goal, and that's what we see. That's what our customers see a lot of times. Well, they'll look at the dashboard, they'll see that there was again a blip, and that the job is able to recover automatically without any intervention from a human at CoreWeave or from them.
No taking down the power grid, right?
No taking down the power grid.
So, do you think we're moving towards a standardized definition of reliability, or do you think every cloud is just going to, kind of interpret it differently?
There's two metrics that we care deeply about at CoreWeave. One of them is called MFU, model flop utilization, and the other one is called good put. So MFU is a measure of your ability to get the maximum performance out of the GPUs that you've purchased while training a model. So things that can affect MFU, for example, is if your network is slow or your network is congested and you're not able to read data into the GPUs as quickly as you need to, or disk performance for the same exact reason that maybe you're not able to get data into the GPUs as efficiently as possible. So that's really, like I said, a measure of like raw performance, you can think of it. And then good put is a measure of really a lot of what the things that we've been talking about is your ability to get to the finish line when you're training a model. So things that can affect good put is one is MFU. If your MFU is not good, then your good put is probably not going to be great. But two, if there are interruptions and your job stops running and you need to resume from a prior checkpoint, that's going to set you back, right? And so why we think about these two metrics is we want to make sure that you're able to get to that finish line just as quickly as possible. What our customers have told us and what our own research has shown is that we're able to have about 20% increase in MFU just by running on CoreWeave, and about an 8% increase in good put, again, just by running your jobs on CoreWeave. So these are the metrics that we believe are important to our customers. It would be great to see a standard because, again, we really believe in our infrastructure and what it can do for our customers. But in the meantime, that's what we're focused on optimizing.
So, thinking about this from the perspective of someone who might be looking into cloud providers and purchasing, GPUs, I'm sure, MFU, good put, this also has a big, impact on total cost of ownership, right?
Yeah, absolutely. Absolutely. Again, your goal when you're an AI lab is to train a model just as quickly as possible, right? And so we've done a lot of analysis on the research papers that have been published. And, one of them specifically talks about the amount of time that it took Meta to train the Llama models. We believe that if those had been trained on CoreWeave, that they would have been able to save about 3.1 million GPU hours just by the increase of good put and MFU that our research has bared out and what our customers talk about.
So in the future, if we had a standardized way of measuring this, I could see, the kind of story being even, clearer between CoreWeave and other providers, right?
Yes, absolutely. So now we get to flip the script around a little bit, Jacob. So Jacob introduced me at the beginning, but what I want to say is Jacob has been at CoreWeave for the last 4 years. He's the leader of the solution architecture team. So Jacob, please tell me, what is the first thing that you look at when a customer has an issue?
Well, the first thing is, depending on if a customer is using something like Sunk or Slurm on Kubernetes integration, I might look at what sort of impact this has had on their job. Look at our dashboards, look in Grafana, and then I love to check our metrics around GPU utilization, around memory utilization, to kind of check to see if any of the obvious stuff is kind of messed up at the start.
Makes sense. How do you communicate those kinds of things to to the customers?
I think it's always about, trying to, keep them in the loop, keep them aware of what's going on in their environment. For certain types of people at AI labs, for example, if you're a researcher, you're not necessarily going to be thinking about the underlying infrastructure, and that's the way it should be.
Yeah.
So trying to, be proactive and, let folks know, hey, we've noticed an issue. It probably shows up, like this on your side. And then trying to communicate, how we can fix it, what kind of metrics they can look at, how they can be involved in the process, I think is always a really, good way of going about it. All right, now I'm going to fire a question back at you. What would you say is one of the more overlooked, causes of poor job performance?
So, we spend a lot of time talking about the GPUs themselves, and that's one part of what customers buy from us. But what our customers really buy from us is an AI supercomputer. And AI supercomputers are the GPUs, the InfiniBand network that connects the GPUs together, the Ethernet network that connects the GPUs to the rest of the world and to store and storage itself. So when you think about what's overlooked, it's really all these other components that are part of the whole. There's a few things that CoreWeave really does differently than other providers. I mentioned InfiniBand already. And so this allows us to have 3.2 terabits of connectivity between every node with 8 GPUs and every other node with 8 GPUs in the cluster. And so that's giving the bandwidth that we talked about so that MFU is not impacted when it comes to training. Also, on the storage side, we have something that we call CHAOS, CoreWeave AI Object Storage, which is a really innovative storage solution. And the part that makes it so differentiated in the market is that it uses the local storage on the GPU nodes to cache content locally. So it allows customers to get much greater throughput when training AI models. So Jacob, what is the most common reliability myth that you see in the industry?
So I think one thing that people definitely don't expect is that not all problems are deterministic. In kind of traditional situations, if you're operating microservices or at a smaller scale, most of the problems you're going to encounter are going to be pretty deterministic. There'll be a direct trail that you can always follow, cause and effect, right? But the truth is, when you're operating at a specific, at a very large scale, so we're talking, thousands of GPUs or tens of thousands of GPUs, even, memory bits at that scale can flip, right?
Mhm.
And that causes issues that don't appear very deterministic. So this is kind of going back to one of the things you mentioned about people sometimes underestimating the challenges of scaling and the expertise that requires. Certainly, some of the most frustrating issues you can find are the ones that are non-deterministic, and they just happen at this kind of scale. They happen when you're really trying to go big with any type of compute, and certainly the kind of compute that we offer. So.
How do you recommend that customers identify and address some of those?
It's a huge challenge, right? So I think we've put a lot of effort into trying to identify those situations, and I think the most effective way is really those day two things we talked about.
Mhm.
Constantly checking your systems, trying to make sure that when that next job runs, you can be confident that every system is ready to go, it's up to the right spec. And you're not gonna, be able to reliably, manually test every node. You need the automation, you need those day two tests to be able to really weed out these really challenging, non-deterministic kind of issues.
Yeah.
All right, so what's one question that you would ask a provider before you were signing a contract for an AI supercomputer?
It's really about how will you support me as a customer. If I have a problem with a node or the network or even my training jobs, and I bring that to you, like what is the communication cadence going to be? Is it going to be that I'm going to get an answer back in a few minutes, a few hours, a few days? And what kind of really what support am I going to get from you as a provider? Because again, these things are really challenging and really hard. And so I think if I was a customer, I'd really want to know that I have a provider that cares greatly about my business.
Right, and in a big way, we care a lot about that. Obviously, that's what you think about. That's what I think about a lot. What do you think is one thing that CoreWeave just really does radically different than other providers in that area?
I can't say for sure what other providers do or don't do, but what we do at CoreWeave is we have Slack channels with every customer that allows us to have a Slack channel with them. And so rather than thinking of like tickets, when a customer has a issue, they send a Slack message. Myself, our CTO, Peter Solanki, and others are in these Slack channels, and we're making sure that those issues get addressed quickly. We of course have an entire support organization whose job it is to monitor those channels and make sure that the issues are routed to the expert that can resolve the problem just as quickly as possible. And that's something I think that really does make CoreWeave very unique.
Right. And customers just genuinely appreciate being able to talk to folks who can answer their questions quickly, and that goes up and down the entire organization, right?
Yes.
Just like you mentioned.
So Jacob, how can you tell if a provider is really monitoring GPU health?
I think it's the way you can tell is if by the time you notice that there's an issue, it's the wheels are already in motion, right? We mentioned this a few times, but the automation needs to save every second. And so, if a provider is not taking action by the time you as a human can see that there's an issue, I think that's a problem. So what does transparency really look like when things go wrong in these environments?
I think it's super important that you as a customer are able to have access to the same data that the provider is able to access when it comes to metrics and logs. And this is where having single tenant access to nodes means that there's no hypervisor in the middle kind of lying to you potentially, right? So the bare metal nodes and the ability for the provider to be able to give you access to those raw logs, I think is critical. So Jacob, I think this will maybe the last question of the day. Tell me what one red flag you would advise customers to be on the lookout for from providers.
I think it's if a provider is telling you that there will never be failures, I think that's the red flag, right? Like even just thinking back about our conversation here, a big takeaway for me, and I hope for some of the listeners and viewers, is that these things happen in infrastructure, and it's more important to prepare for the ways that you can recover and the way you can communicate with your providers than anything. So I think if a provider, is just talking about their uptime or just talking about reliability and not talking about how they, manage those issues, that's definitely a red flag, because that's gonna, those things are things that are gonna really make a difference when something goes wrong. And at some point in infrastructure, at the scale that customers are really operating, something's going to fail at some point, and it's more important to know how to recover, right?
Absolutely, resiliency. That's what it's all about.
Resiliency is key.
Awesome.
Well, thank you, John, for joining me today. I had an awesome time talking through all these topics. I hope folks at home learned a little bit more about GPU reliability, about service level agreements, about some of the unique pieces of AI cloud. And I hope everyone will join us next time when we dig more into the total cost of ownership for AI cloud and see what's next on the horizon.